Welcome to my class. I'm Drew Collop. In today's class, we're going to talk about quadratic equations. We're going to take all the knowledge we learned earlier with factoring and our knowledge of algebra and our knowledge of graphing. We're going to combine it all together to solve some quadratic equations. To start today's class, I'd like you to pause the video. I'd like you to graph these two equations. We have a linear equation and we have a quadratic equation. Use your y-intercept and your slope to graph your linear equation, and use a table of values to graph your quadratic equation. Try that now. Let's take it up. Remember, here's our slope, and here is our y-intercept, which would be the value 0, -3. For slope, we have rise over run. So this is going to be 1 rise over 2 runs. Let's put our scale on here. Before we do that, let's create our table of values for our quadratic equation. Why? I want to make sure my scale is proper. Do 6, 4, 2, 1, 0, -1, -2, and -4. Plug those in. And there's our table of values. Let's put our scale on here. We need to go from 6 to -4 on our x-axis. So we'll have every unit being worth 1. On the x-axis. On the y-axis, we have to go up to +9 and go down to -3.5. So let's make sure we squeeze that in there. Go down to -4 there. That should work well. Let's graph our linear equation. We do this by finding the y-intercept. Y-intercept is -3. We then use our rise over run. We go up 1 and over 2. Up 1 over 2. Up 1 over 2. Looks like our x-intercept is going to be +6. Connect that with a straight line. And that is how to graph a linear equation. Let's now use our table of values to graph our quadratic equation. We have 6 on the x-axis and 9 on the y-axis. First data point. We then have 4 and 1. We have 2 and -3. -1, -1.5. -2 and 1. And finally, -4 and 9. Again, this is not going to be a straight line. This is going to be a curve. So what you can see here is that when we graph a linear equation, we have a y-intercept and we have an x-intercept. When we graph a quadratic equation, we have a y-intercept, but notice we have 2 x-intercepts. This will be important later on. We're going to solve for the roots of our quadratic equation, also known as our x-intercepts. Our quadratic equation, this is a common term used for an equation that has a polynomial with a second-degree term. This is the general form of a quadratic equation. So hopefully you see from last time we were factoring trinomials. We have our ax squared plus bx plus c, and now we're making it equal to y. So here we have 2 variables. We have a constant c, and we can have 2 other coefficients on our second degree and our first degree terms. Let's look again at the difference between linear equations and quadratic equations when we graph it. Here we have y equals x. That's just going to look like this. It's going to go off at a 45-degree angle. We can put a coefficient in front of our x. Y equals negative 2x. This is going to have a negative slope, and it's going to be twice as steep. It's going to look like that. We can also have y equals x plus 3. What this does, just moves my y-intercept to 3, but my slope remains the same as my y equals x. That's what happens when we add in constants and coefficients into linear equations. Let's see what happens when we do the same thing with a quadratic equation. Y equals x squared. This looks just like this. It has one x-intercept at 0, 0. Let's apply our coefficient on our variable, negative 2, just like we did for our linear equation. What does that do? Well, it flips that curve upside down, and it makes it twice as steep. So now it's going to look something like that. Flips it over, makes it twice as steep. Once again, there will still be one x-intercept here at the origin, 0, 0. If we add a constant to this, what happens now? Well, you can see over here, it moved it up 3, does the same thing here. In this case here, we take the red line and we just move it up, so the y-intercept is at positive 3. It's exactly the same curve, though. What is our x-intercept here? Notice there is not one. So sometimes when we solve quadratic equations, there is no x-intercept. This will be important moving forward. Let's look at solving quadratic equations. How do we do that? What we do, to solve it, we set y equal to 0, and we solve for all the values of x. What we're looking for here is the x-intercepts. Remember, when we were doing graphing of linear equations, we could calculate the x-intercept by setting y equal to 0. That's what we're doing here. These are sometimes called the roots of the quadratic equation. We will be doing this algebraically, but let's first look at it graphically. So what is the solution to this quadratic equation in A? What does that mean? What are my roots? It's here and here. What are my x-intercepts? So x is equal to 0, and x is equal to 2. Notice there are two correct answers for this. What about B? I only have one answer. X is equal to 0. Sometimes there are two answers to a quadratic equation. Sometimes there's only one. Let's examine C. C, we flip that graph upside down, but we still have two solutions. Negative 1 and positive 2. What about D? What are our x-intercepts here? Notice it comes nowhere near the x-axis. So what do we say here? We say this has no real roots. I show you this because when we work with this algebraically, sometimes you will have two solutions to your answer. Sometimes you will only have one solution, and other times there will be no solution. So those are your three options when you're solving quadratic equations. Oftentimes there are two correct answers. Sometimes there's only one, and sometimes there is no solution. Let's find the roots of some of the following quadratic equations. So we're asking to find the roots, which means we find x after we set y equal to 0. So here's our equation, y equals x squared. First thing, set y equal to 0. I get 0 is equal to x squared. I take the square root of both sides. Square root of 0 is 0. There is only one answer to this. X is equal to 0. If you were to graph it again, it would look something like this. The x-intercept is at the origin. Let's look at the next one. Y equals x squared minus 4. set y equal to 0. 0 is equal to x squared minus 4. Let's try and isolate x on its own. Move the 4 to the other side, becomes positive 4. I have x squared. To get rid of the squared, I square root both sides. Remember, I can do whatever I want to one side of the equation, as long as I do the same thing to the other side. I take the square root of x squared. It's just going to give me x. Square root of 4 is 2. But remember, when we're doing algebra and we have to take the square root, there are going to be both a positive and a negative answer. So x is equal to both positive and negative 2. If we were to graph that, it would look something like this. This would cross at minus 4, and we would have 2 x-intercepts. Do you see an alternative way to solve this? What is this? This is a difference of squares. Let's examine that for a second. 0 is equal to x plus 2, x minus 2. So here we can take our knowledge of factoring. We can work this out. What I can do here, you've probably learned this in the past. You put x plus 2 equals 0, and you put x minus 2 equals 0. And you solve that, right? So x is equal to minus 2, and x is equal to positive 2. 2 correct answers. Same as what we got over here. What you may not know is why this works. Well, here, if I set this equal to 0, it doesn't matter what this is. The whole thing's going to be 0. Likewise, if I set this equal to 0, it doesn't matter what this is. Whatever this is times 0 is still going to be 0. So that's why this works. So here we can take our knowledge of factoring, and you can see why there are 2 answers. Let's try the next one. So we're going to set y equal to 0. 0 is equal to x minus 5 squared. Let's square root both sides, the whole thing. Square root of 0 is just 0. X minus 5. Swing the 5 over to the other side. X is equal to 5. There is only one answer to this one. Why is that? This would look like this. There's only one solution. Let's try D. Set y equal to 0. X plus 2 squared minus 9. Swing the 9 over to the other side. 9 is equal to x plus 2 squared. Square root both sides. We have x plus 2 equals the square root of 9, which is going to be both plus and minus 3. This becomes x is equal to negative 2 plus or minus 3. So there's going to be one answer, negative 2 plus 3, which is going to be x is equal to 1. And the other answer is going to be negative 2 minus 3. It's going to be negative 5. So you can see there are 2 answers to this one. Do you see an alternative way to solve this? Look it's a difference of squares. I can take the square root of this, and I can take the square root of this, and it's a difference. Let's solve it using difference of squares. X plus 2 plus 3 and x plus 2 minus 3. Set both those sides equal to 0. X plus 2 plus 3 equals 0. And x plus 2 minus 3 equals 0. I can drop the brackets. X plus 5 equals 0. X is equal to negative 5. I can drop the brackets here. X 2 minus 3 is minus 1 equals 0. So x is equal to 1. Again, same answers here and here. So 2 alternative ways to solve this. We can solve this using square root symbols, or we can solve this with our understanding of difference of squares. But you can see once again, we get 2 correct answers. What this should look like? It would look something like this, where it crosses at 1 and it crosses at -5. Let's examine this one. Are there any tricks I can do? Can I pull out a common factor? Can I use difference of squares? Can I factor a simple trinomial? No, there's nothing else we can do here. We'll solve for the roots, set y equal to 0, swing the 4 over the other side, becomes -4, equals x squared. Looks pretty easy so far. Square root the x squared, and we'll square root the -4. So we get x is equal to... What's the square root of -4? Try that with your calculator right now. Give it a try. You'll get an error. It doesn't work. Why? Because we can't take the square root of a negative number. There are no 2 of the same numbers that multiply together to give me a negative value. A positive times a positive is a positive. A negative times a negative is a positive. So there is no solution to this. This is no real roots. What do I mean by real? Well, we can solve this, but we have to work with imaginary numbers. Go all the way back to lecture 1. Probably in the first 10 minutes, I introduced different types of numbers. We will not be working with imaginary numbers in this course. But often in engineering, you do have to take the square root of a negative number. There is an alternative math to do that. We will not be discussing that here. So your answer to this would be there are no real roots. What does this look like on a graph? Like this. You can see there are no x-intercepts because it's all above the x-axis. The point of this exercise here is to try and inform you there are 3 possible answers you can get when solving a quadratic equation. Quite often, you'll get 2 correct answers. Sometimes you'll get 1 correct answer, and sometimes you will have no real roots. There will be no solution to this problem. Remember that. Now, when solving these, I solve these just using basic algebra, square rooting both sides. I also started to show you how you could factor this. Oftentimes, when you have more complex quadratic equations, the basic principles of algebra will not work. You have to bring in more complex things, such as factoring. Sometimes that won't even work. And today, we're just going to talk about factoring. So technique number 1. There'll be 3 techniques in total: factoring, completing the square, and the quadratic formula. Today, we're just going to talk about factoring. Before, when we were factoring, we didn't get an answer because we were only factoring expressions. Expressions are not equal to anything. You can't solve for x. Well, now we're going to make it equal to something, in which case we can solve for x. Let's solve this now. What do we have here? How can we solve this? I can pull out a common factor. What's my common factor between x squared and x? It's going to be an x. So I can take an x out. I got x plus 1 equals 0. Now remember, if this is equal to 0, it checks out. If this is equal to 0, it also checks out. So, if either factor is equal to 0, then the entire expression is equal to 0. Remember that. We can now solve this. X is equal to 0 and x plus 1 is equal to 0. So x is equal to 0 and x is equal to -1. So you can see we get 2 correct answers. Remember, you can always sub those in and check. If this is 0 and this is 0, then the other side is equal to 0. If this is -1, -1 times -1 is +1, and then I add -1. +1 minus 1 is 0. So you can see those are 2 correct solutions. Let's try the next one. Example 4. What do you see here? This looks like the other one. I'm going to do something here, but please, this is incorrect. So if you did it like the last one, we could take an x out. X plus 7 equals negative 10. And then what some people might do is they say x is equal to minus 10, and x plus 7 is equal to minus 10. So x is equal to negative 17. Two correct answers. Wrong. Those are two incorrect answers. We can only break this up like this if this value is equal to 0. It must be equal to 0. So we're not going to do any of that. Instead, what we're going to do is we're going to make the other side equal to 0 by rearranging the equation. X squared minus 7x, move the negative 10 to the other side, becomes positive 10, and that's equal to 0. So that's what we want to do. We want to set this side equal to 0. What do you notice about this? This is a simple trinomial. Looking for two numbers that multiply to 10. Those same two numbers need to add up to negative 7. Oh, made a mistake there. That should be positive 7. Always double check your work. So I'm looking for two numbers that multiply to 10 and add up to positive 7. It's going to be 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. X plus 5 and x plus 2 equals 0. Again, if this is equal to 0, it doesn't matter what this is, the whole thing will be 0. And vice versa. So x plus 5 can be equal to 0, and x plus 2 is equal to 0. X is equal to negative 5, and x is equal to negative 2. Two correct answers. So remember, we can only break that up if that's equal to 0. So rearrange the equation and make one side 0 and everything else on the other side of the equation. We have a large number of practice questions here. A, B, C, D, E, and F. Oh, and G and H. So a lot of questions here to practice on. So we're solving for x here. Try these on your own. I'll write down the correct answers. I'll take up some of them. Those that I don't take up that you still have an issue with, you can ask me outside of class. Give this a try now. Let's take some of these up. A and B, I don't think are too challenging. Let's take up C. What do you see here now? Let's rearrange the equation. 6x squared plus 2 minus 7x equals 0. Let's put it in our proper quadratic equation form. And there you have it. Can we take out a common factor? We cannot. This is going to be a complex trinomial. Looking for two numbers and multiply. 6 times 2 is 12. And add up to negative 7. Those two values will be negative 3 and negative 4. We will now decompose that center term. We'll pull a common factor out from those and from those. We'll then group those together. And now we can solve. So I have 3x minus 2, that can be equal to 0, or 2x minus 1, that can also be equal to 0. 3x equals 2, divide both sides by 3. Those cancel each other out. X is equal to 2 over 3. Over here, same thing. Move the negative 1 over the other side, becomes positive 1. Divide both sides by 2. And x is equal to 1/2. So here we have two answers, 2/3 and 1/2. I don't think D is too challenging. Let's do E. There are 3 correct answers to E. Let's try that one. I think I might need a bit more space. I'm just going to erase these. Step number 1. We have a cubic function here, x cubed. But notice I have a common factor of x in all of them. I also have a common factor of 2. So first things first, to make my job easier, always see if you can take out a common factor. I can take a 2x out, leaving me with now I have a complex trinomial. I'm looking for 2 numbers that multiply to -6 and add up to -5. Those 2 values would be -6 and +1. Now remember, this 2x, this factor you took out, it has to remain with it. Again, I don't know why, but many times when students, they factor out this value, it just disappears on the next line. It can't disappear. It's part of the equation. Let's decompose that complex trinomial. Pull a common factor out from there and there. We have the same values here and here. We can pull that out as a common factor. And we've factored it. Now you can see that's why there are 3 solutions. 2x equals 0, 2x plus 1 equals 0, or x minus 3 equals 0. Divide both sides by 2, x is equal to 0. 2x is equal to -1, x is equal to -1/2. X is equal to +3. So you can see that's why there are 3 correct answers to this equation. Let's do F. F looks challenging. It shouldn't be, though. Let's copy that down here. 3x squared plus 2x equals 1. Let's think back to earlier lectures. When we have an equation with fractions in it, what do? We get rid of them. Let's get rid of them here by multiplying every side by x squared. When I do that, I have 3x squared over x squared. Remember to distribute to both the values there. 2 times x squared is 2x squared over x is equal to x squared. See what happens? X squared cancels out x squared, and this x cancels out one of those x's. I then get 3 plus 2x is equal to x squared. Swing everything over to one side, x squared minus 2x minus 3. What do you got? You got a simple trinomial, guys. So I'm looking for 2 numbers that multiply to -3 and add up to -2. Those 2 values will be -3 and +1. Factor it now. X minus 3, x plus 1, x minus 3 equals 0, or x plus 1 equals 0. X is equal to 3, and x is equal to -1. 2 correct answers. Let's do one more. We'll do g together. I like g. G's a challenging one. Let's rearrange it now. What do we have here now? We have x to the exponent 4. What can we do? Can we pull out a common factor? We cannot. What I can do is I can do substitution. Remember substitution? Let w equal x squared. So when I do that, 3, this would be x squared squared minus 7x squared minus 20 equals 0. So I can take my x squared and replace it with my w. Let's do that on the next line. 3w squared minus 7w minus 20 equals 0. Again, I've replaced x squared with w. What do we have here now? We have a complex trinomial looking for two numbers that multiply to negative 60 and add up to negative 7. Those two numbers will be negative 12, positive 5. 5 minus 12 is negative 7, and 12 times 5 is going to be 60, but it's negative 12. So negative 12 times 5 is negative 60. We can decompose that middle term into negative 12w and positive 5w. Pull a common factor from there and there. We have the same value here and here. We can take that as a common factor. And then we can break it up. 3w plus 5 equals 0, and w minus 4 equals 0. 3w equals negative 5. W is equal to negative 5 over 3. And here we get w is equal to positive 4. Is that our final answer? It's not. We're not asked to solve for w. We're asked to solve for x squared. So let's sub back in our x squared. X squared is equal to negative 5 over 3, and x squared is equal to 4. Make sure you put that back in. This side's pretty easy. Square root both sides. So x is equal to both positive and negative 2. Two answers there. Do the same thing over here. Square root x squared, square root a negative number. Guess what? Doesn't work. No real roots. So what do we write here? We write invalid. This is not a solution. So there are only two correct answers to this one. X is equal to positive 2 and x is equal to negative 2. We can also use this knowledge to solve word problems. Let's try I together. Find a quadratic equation in the form of y equals ax squared plus bx plus c. It has roots of 4 and negative 6. This is actually enough information to get the equation for this particular line. Right here, it says the roots are 4 and 6. This means our x-intercepts are at 4 and at negative 6. What we do here, we just do the reverse of what we've been doing before. Let's rearrange this, make this equal to 0. Rearrange this, make this equal to 0. Then, x minus 4, x plus 6 equals 0. Now let's FOIL it. X squared plus 6x minus 4x minus 24 equals 0. Combine like terms, x squared plus 2x minus 24. We don't want it equal to 0. We want it equal to y. So y is equal to x squared plus 2x minus 24. Here is your quadratic equation with the roots 4, negative 6. Let's work through j together. The height h in feet, an object falls after t seconds, is given by this equation right here. H is equal to negative 16 times time squared plus 25 times time plus 50. The question is how long will it take for the object to hit the ground? How do we solve this now? You have to think about this. If we take an object, we throw it up in the air, hits the ground. What's the height? Height is going to be 0. But if we throw it from the ground, there'll actually be 2 correct answers. So what we're going to do is we're going to set height equal to 0. This will be when the object is on the ground. Now we can solve this. This looks like a challenging one. We have a complex trinomial. We're looking for 2 numbers that multiply to negative 800, and those same 2 numbers should add up to 25. What 2 numbers are those? This is too challenging to solve using factoring. This is as far as we can go with the knowledge we have right now. We will come back to this problem later on when we learn a new technique in our next lecture. So sometimes factoring will not work with some of these quadratic equations. Thankfully, there are 2 other methods we can work with. One of them is quite challenging, and one of them is very easy. That'll be our topic of our next lecture. Last problem of the day, word problem. Please try this one on your own. The length of a rectangle is 3 centimeters more than 5 times its width. If the area of the rectangle is 92 centimeters squared, find the length of the rectangle. Remember, create your let statement and your therefore statement. Many of you lost marks in the last assessment because you failed to write a let statement and you failed to write a concluding statement. That's a silly waste of marks. Try this now on your own. Here's your answers. Let's take this up. So we have a rectangle. It has a length and it has a width. It says here, the length of the rectangle is 3 centimeters more than 5 times the width. Let's create our let statements. Let W be the width in centimeters. Let L be the length in centimeters. Let's now build our equations. Notice we have 2 unknowns. How many equations do we need to solve 2 unknowns? Going back to systems of linear equations. I will require 2 different equations to solve 2 unknowns. Let's build those equations now. The length of the rectangle compared to the width of the rectangle. It says the length of the rectangle is 3 centimeters more than 5 times the width. So I'm going to multiply the width by 5. And the length is 3 centimeters more. So to make them equal, I have to subtract 3 away. So here is equation 1. What's my next equation? The area of the rectangle is 92 centimeters squared. So my area is equal to my length times my width. What is my area? My area is 92 centimeters squared. Length times width. Here is equation 2. I'm just going to leave the units out for now. What do I do now? Well, let's solve for L over here. L is equal to 5W plus 3. And now we can substitute in for L over here. Let's do that now. 92 equals 5W plus 3 times W. Distribute my W here and here. 92 equals 5W squared plus 3W. What do we do now? Rearrange it to make one side 0. And here we have a complex trinomial. So you can see this is very similar to one of the problems we may have done with systems of linear equations. But here we don't have a linear equation, we have a quadratic equation. So you need new skills to solve this. Hopefully you have those now. Let's work through this together. First things first, can we factor anything out? We cannot. This is a complex trinomial. I'm looking for two numbers that multiply to 5 times negative 92, which is going to be negative 460. I'm looking for those same two numbers that add together to give me positive 3. It's going to be a lot of guessing here. I'll save you time. We have 23 and negative 20. What we can then do is we can decompose this middle term. 0 is equal to 5w squared minus 20w plus 23w minus 92. I'll pull a common factor out from these two and from these two. You can see we have the same value here and here. Therefore, that is a common factor. Therefore, I can take that out. And this is what I get. Let's now break it up. 5w plus 23, if that's equal to 0, then the whole equation is equal to 0. W minus 4, if that's equal to 0, the whole equation is equal to 0. Solve this one, w is equal to 4. Solve this one, 5w is equal to negative 23. Divide both sides by 5. Cancel each other out. W is equal to minus 23 over 5. Looks like there's two answers. What are our units here? Well, it's going to be in centimeters. Can we have negative centimeters? For measuring something, can we have a negative value? No, we cannot. Therefore, we say this answer is invalid because it breaks logic. Is this our final answer? Is this what we asked to solve? Find the length, not what I was asked to solve. So I have to sub the w in to solve for the other value. We had length minus 3 is equal to 5w. Let's sub that in here and we'll solve for our length. Length minus 3 equals 5 times 4. Length minus 3 equals 20. So length is equal to negative 3 becomes positive 3, 23. Therefore, the length is 23, our units, centimeters. And the width is 4 centimeters. Final answer. This is a great question. Why? Because you have to utilize so many different skills in mathematics. You have to understand how to do word problems. You have to understand how to build equations. You have to understand how to combine equations, systems of linear equations. You have to understand how to decompose a complex trinomial. A lot of concepts in play here. I've said this before, I'll say it again. When you get to higher order math, there are some very challenging concepts, but for the majority of things, it's not too challenging. The challenge is that you're doing all of the basic concepts at one time. If you have a lack of understanding in any single one of those concepts, you will not be able to proceed with that solution. So please study those things that you're unclear of. Make sure you master these skills if you'd like to move forward with higher order math. So in today's lecture, we combined everything. We combined our factoring, we combined solving of equations, graphing. In our next lecture, we'll examine what we do when we cannot simply just factor this quadratic equation. The two methods are difference of squares and the quadratic formula. That's all for today. Until next time.